3.5 talks about complex zeros in the fundamental theorem of algebra, and here it is. Fundamental theorem of algebra states, given a polynomial has complex coefficients, if you recall, these are the coefficients. Ooh, that's misspelled. I thought it picked up. Coefficients. Then the polynomial has at least one zero. So given that f of x has complex coefficients, then the polynomial has at least one complex zero. The factorization theorem states, if f of x is a polynomial of degree bigger than or equal to 1, then f of x can be expressed as the product of n factors where all of these zeros, c1, c2, c3, and this number right here, belong C, and C is the complex plane. C means imaginary number. Or complex plane. Well, a polynomial f of x is given, find all the zeros, factor completely. So if this is x to the fifth, I should be able to see all of these zeros. Of course, you have to add multiplicities. Well, this I could factor. I could factor 2x cubed out. I'll have x squared plus 4. So the zeros would be x equals 0, multiplicity 3. And if you set that equal to 0 plus or minus 2i, so I could write f of x as 2x cubed into x minus 2i into x plus 2i. And that's sufficient. This problem right here, well, this factors, I could take x to the fourth minus 3x. Actually, let me factor it right away. So that would be, so I'm going to set that equal to 0 to find all the zeros. That's x squared and x squared minus 4 and a plus 1. So that's x minus 2, or it doesn't really matter because I have to find the zeros. I would say the zeros are plus or minus 2 and plus or minus I. So I could write f of x as x minus 2, x plus 2, x minus I, and x plus I. And that would be my answer. I get to the last example out of these types, and this doesn't seem to factor. Well, remember, the possible rational zeros are plus or minus 1 divided by 2, divided by 1. So it's only plus or minus 2, that's it. Well, does 1 work? 1 minus 1 is 0, 2 plus 2, that doesn't work. Negative 1? If I try negative 1, I'm looking at 1 minus 1 minus 2 plus 2, that is 0. So negative 1 works. Very good. Well, don't forget, x to the fourth, there is no x cubed. X squared, x, and the number. So if I work these out, drop the first number, that's a negative 1. That is a 1, that's a 0. Well, does negative 1 work again? That would be nice. Right, negative 1, negative 2, that's a 2, that's a negative 2. Awesome, that does work. This is quadratic. This is x squared minus 2x plus 2 equals 0. So x squared minus 2x, take half of the middle number and square it, that's a 1. So this is x minus 1 squared equal negative 1. When I square root both sides, I get a plus or minus I. So I could say the zeros are negative 1 multiplicity 2 and plus or minus I. So I can write f of x as x minus 2, x plus 2, I'm sorry, it was multiplicity 2, I messed up, x minus 1 squared, x minus I into x plus So if things don't factor, if polynomials don't factor, you can no longer save time now that you know about the rational possible zeros and so on and so forth. If I gave you the zeros, can you give me the equation? Find a polynomial with integer coefficient that satisfies the given condition. G of x has degree 2, and the 0 is I. Well, x minus I, and what? Where did that blue part come from? Where did x plus I come from? Well, complex numbers come in pair. The only way to get a complex number if you square both sides and you pick a plus or minus. So, any complex number, if a complex number is a 0, its conjugate is automatically a 0 as well. And you could multiply, you don't have to. This is going to be the first squared minus the second squared, which is x squared minus, remember that's a negative 1. So really, g of x is x squared plus 1. And find h of x. Okay, what's h of x? Degree 4. The zeros are 0, so x minus 0, or you could just say x, 2, x minus 3i, and automatically the conjugate of that is also a 0. So again, on a test, this is all I want. You don't need to simplify. You want to match it with the back of the book. This is conjugates. Conjugates, you guys, if you recall, that's going to be the first squared minus the second squared, 9i squared. H is going to equal x into x minus 2, and this is going to be x squared. I squared is negative 1 times a negative 9 is a positive 9. So that would be x into, and if you FOIL this, x cubed minus 2x squared plus 9x minus 18. So h of x, you could say, is x to the 4th minus 2x cubed plus 9x squared minus 18.